Okay, I wanted to start off this video for lesson 32, solving rational equations, with a little bit of a warning. And it's that mastery in math doesn't come from watching videos or paying attention in class. It comes from solving problems yourself. Now, watching videos and paying attention in class are part of what can help you get there, but that's not an indication of mastery. If you can't solve problems yourself, these videos are to help get you there. But until you can take the videos and the notes away and solve some problems on your own, you haven't mastered the content. So you need to care if you can do these by yourself. No notes, no video, turn it all off, and then do an example yourself, or a few examples yourself, and then you can say that you've mastered it. All right, now, there are a couple different ways that we can approach solving rational equations, so I'm going to focus on one in specific, but I'll show you a couple. So I'm going to pull a question from the beginning, and that is question number 1. I'm going to rewrite it so I can pull it over to my notes. 3 over x squared is equal to 1 over x squared plus 1 over x. Now, there are two methods in general, call them two methods, that you can use to solve these. When I look at this, I see that I have two denominators that are the same. My goal, first and foremost, is to turn three fractions, and then we can hopefully cross multiply. Now, there are two ways to do that. I'm going to do them both for you. We have the option of we can move like terms next to each other. GCFs, I got GCFs on the brain. We can create like denominators. Okay, so we got to take these adjacent terms, ones that are next to each other, and we could either move them or we can create ones that are already next to each other. So let me show you what that looks like. Start off with the original question here. 3 over x squared is equal to 1 over x squared plus 1 over x. Now, if I want to get this term and this term to be next to each other, there's a problem. There's an equal sign in the middle. They have the same denominator, so I would love it if they were next to each other, but they're not. So the way that I can make them next to each other is I can subtract 1 over x squared off of both sides. These will cancel out. What I'm going to get next is 3 over x squared minus 1 over x squared, and that's equal to 1 over x. Now these two on the left have the same denominator with a subtraction in the middle, so I can smush them together. So that means it becomes 3 minus 1, 3 minus 1, over the common denominator, which is x squared. And that's still equal to 1 over x. What I can do now is I can cross multiply these. 3 minus 1, by the way, is 2, so I'm not going to rewrite that as 3 minus 1. It's just 2. You can even do this. 2. Okay, so cross multiply those. Gets me 2x is equal to, the other diagonal is 1 times x squared, which is x squared. To simplify this, I notice that both sides have an x, so I'm going to divide by x, divide by x. X squared divided by x is just x. So I'm going to get, in the end, 2 is equal to x. That's what you're trying to solve for. You're trying to solve for like an x equals. If you want to follow that back, rewind, watch through it again. The other way that I can do this is I start with the same exact equation, 3 over x squared is equal to 1 over x squared plus 1 over x. Now, if you don't feel like moving terms, which two terms are next to each other already? These two are. But the problem is they don't have the same denominator. How could I turn them into the same denominator? Well, x squared and x, it would be really easy to do this, and now technically isn't this x squared? Whenever you do that, remember you have to multiply by the same thing on the top and the bottom. You can't forget that. But now look, they have the same denominator. So when I rewrite, I'll get 3 over x squared is equal to 1 over x squared plus x over x squared. Now, since these two on the right have the same denominator, I can smush them together. 1 plus x over x squared. That's equal to 3 over x squared. Now I can cross multiply these. 3 times x squared is 3x squared is equal to x squared times 1 plus x. Now these have something in common. These both have an x squared in them, so I'm going to divide it off. I'm allowed to do that because both of the x squareds are attached with multiplication. Division cancels that out. So now I get 3 is equal to 1 plus x. Subtract 1 off both sides, and you get that 2 is equal to x. The same exact answer we got on the other side. Now it's up to you. Sometimes you might want to move like terms next to each other. Sometimes you might want to create like denominators next to each other instead of moving things. It's really up to you. Now for one more example, I'm going to show you my favorite way to do these, and I'm going to do it with a more complicated question. So let me pick one from the bottom of the page. Let me do question number 11. I'm just going to rewrite this so I can pull it over to the other page. 4 over v squared plus 2v minus 3 is equal to 1 over v squared plus 2v minus 3 minus 1 over v plus 3. Alright, so question number 11. I don't want the highlighter, I wanted the eraser. Okay, now I gave you guys a warning when we did this in class. My warning said that if denominators can be factored, factor them first. So you might notice that this can be factored, and so can this. So that's what I'm going to do. I got lucky, actually, because these two are equal. They're the same exact thing. So when I figure out how to factor out one of them, I can just rewrite the other one too. I don't need to do two separate kinds of factoring. So here's what I'm going to do. I'm going to do a little bit of scratch work over on the side because I want to figure out how to factor this. V squared plus 2v minus 3. Now I notice that there's a 1 on the front of here, right? So that means I'm allowed to do this kind of factoring, a and m. So two things that'll multiply to negative 3. It's going to be either 3 times negative 1, or it's going to be negative 3 times positive 1. Which one of these will add to get me 2? It's going to be this. So that means that this can be double bubble factored, v and v, into these numbers, plus 3 and minus 1. Okay, so the denominator, that's what it's really equal to. So I'm gonna pull that back over into here, and I'm gonna rewrite. We'll go dark red. Okay, so when I rewrite these, they're gonna be rewritten as this: v plus 3. V minus 1. V plus 3. V minus 1. And I don't like that because it looks a little messy, so I'm going to rewrite the whole thing. 4 over V plus 3. V minus 1 equals 1 over V plus 3. V minus 1 minus 1 over v plus 3. Now the method that I really like to use when I do these questions is I like to give all of the fractions the same denominator. Myself some space. I keep pulling open the side tray. Give all fractions the same denominator. That's with multiplication, by the way. You can't just like do that however you want. Same way we've been doing common denominators with multiplication. Then you can cross all denominators out. It's my favorite. It feels like a giant trick. So you can cross all the denominators out. So here's what I'm going to do. I have v plus 3, v minus 1, v plus 3, v minus 1, and over here I just have v plus 3. So what am I missing? What can I multiply it by? I can multiply it by v minus 1. But whatever I do on top, or rather whatever I do on bottom I have to do on top. So this is really 1 times v minus 1. This is just v minus 1, right? Just doing a simplifying step without rewriting. Back up if you want to see what the hell I did. Alright, so what we're going to do is we're going to... These two have the same denominators, we can smush them together, right? No! If you give all fractions the same denominator, you can cross all the denominators out. Well, let's see. This is v plus 3v minus 1, v plus 3v minus 1, v plus 3v minus 1. They all had the same denominator, so let's cross them all out and make our life a lot simpler. So what do I have left? 4 equals 1 minus v minus 1. The reason I put the parentheses is because this negative is going to have to get distributed. 4 is equal to 1 minus v, negative and negative 1 is, so plus 1. These two are like terms. 1 plus 1 is 2 minus v. still equal to 4. And I'm going to subtract 2 from both sides. 2 is equal to negative v. You can divide by negative 1 if you want to be fancy like that, to cross out the negative. And you would get that v equals negative 2. Okay? V is equal to negative 2. So like I said, that's my favorite trick. Give all fractions the same denominator, then cross all the denominators out. This is the way you do it when things need to be factored. Okay, we didn't learn to factor just to forget about it. So if you're rusty on this, go back to one of the earlier lessons on factoring, do a couple examples, watch through a video. I'm going to do one more just to show you this method, the method 3, because like I said, it's my favorite. Let's pull one off the front page that I like. I know that we did this in class, but I think I would like to do question number 10 anyway. So I'll rewrite so I can pull it over to my other page. And I'll do this one quickly because I've already walked you through everything. Oop, didn't mean to change pages. Okay. Question number 10. I'm doing the same exact thing that I did in the last question. Same rules. Things can be factored, so I'm going to factor them. Okay, it's question number 10. Now here's what I see. I see that this has a GCF. So I'm going to factor out an n. So this becomes n plus 5. 2n is as simple as it's going to get. This can get simplified. I can pull out a 2, and I can also pull out an n. So I'm going to pull out a 2n, leave me with n, divide 5 by 2 and you get 5, pull out the n, so there's no n left. Okay, so it's like if I really want to check if I was confused, I could distribute back in and I would get this. Okay, so I've successfully pulled out the GCF. This is my new denominator. Rewrite just to clean it up for you. 1 over n plus 5 minus 3 over 2n is equal to 1 over 2n n plus 5. Okay? Now, I want to use my method 3, which is give them all the same denominator. So if you take a look, 2n and 2n, right? But this one is missing something. It's missing the n plus 5. So I'm going to multiply by n plus 5 on bottom, n plus 5 on top. Now let's see. I have 2n n plus 5 on both of these. But this guy is only n plus 5, so I'm going to have to multiply by a 2 on the top and the bottom. Now take a look. They all have the same denominator. So what am I allowed to do when they all have the same denominator? Cross them all out. When I rewrite this, I'm going to simplify it. 2 times 1 is 2. Minus 3n minus 15. Because this is like a negative 3. Think of it like that. This is like a negative 3 getting distributed onto both of these. Equals 1. Now let's combine some like terms. 2 minus 15 is negative 13. Minus 3n equals 1. I want to get the n by itself, so 2 more steps. Plus 13, plus 13 on the other side. Negative 3n is equal to 14. And I can divide both sides by negative 3. My final answer is n is equal to 14 over 3, and it doesn't matter where you put this negative sign as long as it's on there. So you can put it up top, you can put it up front, you can put it on the bottom, it doesn't matter. I'm going to put it on top because I like seeing it that way. Okay? And that's how you would do it. If I move too quickly, back up, watch the question again, take away all the notes, and try it yourself on a fresh sheet of loose leaf. Remember that your homework for tonight was questions 6, 7, and 8. Questions 14, 15, and 16. Okay? So hopefully this video is helpful. If you have any more questions, please feel free to contact me. See you in class tomorrow.